Hi. The backstory in this episode is the launching of the project funded by Ministry of Environment and Forests, which I called River Metamorphosis due to human intervention, an example from the Nayar River Basin, Kerala, or rather Nayar Basin, Kerala. I borrowed the word metamorphosis or word pair river metamorphosis from a USGS professional paper authored by Professor Stanley Chem of Colorado State University in US. What Professor Chem did in the professional paper was a reconstruction of the evolution of the Murrumbidgee River Basin in Australia over two different climates or climate zones. Currently, the Murrumbidgee River Basin enjoys a semi-arid climate, while in the past, in the geologic past, the climate there was more humid in the basin, and interestingly, Dr. Chem has pieced together huge evidences, visual as well as measured evidences, in order to justify, in order to explain the features in the river basin, in the channels, in the tributary channels, etc. of Murrumbidgee River Basin due to the past climate and whose vestiges are still retained in the newer climate, which is a semi-arid one. So in other words, it is kind of a metamorphosis is used to explain how a river basin evolved through two different climates. That is what Professor Stanley Chem attempted in this USGS professional paper. Well, United States Geological Survey or USGS occasionally brings out professional papers, as they are called, and these are based on basic research by the USGS personnel themselves or by such geologists who work like Stanley Chem, who work outside the fold of the United States Geological Survey. In fact, when our CES was formed and founded by Sri C. Karnakaran Sir, one of the things the scientists there associated with this did was publication of some professional papers. Unfortunately, these professional papers are in a sort of a book form. Remember 1978 to 80 in a book form, and are available only in a handful of libraries, and in fact probably never consulted by anybody, because people don't know. Such basic studies have been published on the geomorphology of Kerala or the fluvial process of Kerala, etc. by the newer generation. Okay, that much for CES and the professional papers. Okay, however, the Geological Survey of India is not in the habit of publishing any professional paper, either by the scientists, scientific workforce attached directly to the Indian Geological Survey of India, or the compendium of a study by any group or any individual geologist working outside of the Geological Survey of India, but attached to the universities or IITs of India. Well, anyway, you cannot change the mindset of Indian organizations and the top leaders sitting at the helm of the organizations, because once you reach the helm, you cease to become a scientist. You are just a pen pusher, and you have attend meetings and you forget all about science. Unfortunately, that is what happens in respect of every Indian research organization. There could be exceptions, absolutely no doubt about it. But in general, any average Indian research institute and the head of those institutes, they totally retire from the scientific work and do the administrative job. And this has been doing a great harm to Indian science. Our administrators or the ministers or the government of India has not paid any attention to this deterioration or this, what is called a status quo of the organization, existing in the organizations, prevailing in the organizations. Okay, that is that much about my comments on the organizations, scientific research organizations of India. Now back to River Metamorphosis. My staff included B. Rajashekharan, who is deceased now, and was actually finally retired from the University College or the Collegiate Education Department as a professor of geography. Then Mr. Subramani Iyer, who worked in our research project, but later on, before the conclusion of the project itself, Subramani Iyer was recruited by the Oil and Natural Gas Commission, and E.J. Koshi, now after the project tenure, he joined the Indian Rare Earths Limited as a petrologist. These are the three research fellows. Then we have Reena Ravindran, an MSc in chemistry as a technical assistant in chemistry. We had a Ganeshan, who is a technical assistant in geology, and Mr. Vijayakumar Nair, a draftsman surveyor. So this is the complement of staff. Then what about the equipment? The project also had enough funding for buying equipments which were considered vital for the smooth running and of the project in order to achieve the goals goals set for the project. And the equipment complement was never objected to by the reviewers of my project, I suppose. Out of that, I had purchased what is called a Carl size Gina microscope, which is a photographic equipment or attachment. It is not quite a bad one for the price we paid. Then another thing, we acquired a piece of equipment that we acquired for the project under the auspices of the project was a Sartorius balance made in West Germany. Those days, we had two different Germanys. Whereas the microscope came from the East Germany, of course. Whereas the Sartorius balance came from is a microbalance and electronic balance. Okay, and that was acquired from West Germany. Then I had also purchased what is called a Sartorius filtration unit. It is a passive filtration unit, and that is actually that is actually one of the things that has been used in the estimation of the what is called suspended load in the water samples those days. In other words, whatever the equipment has what is called a Sartorius filter also. This Sartorius branded filter. filter paper, circular filter paper. And this is a very interesting thing, it is divided into divided it like a graph sheet in millimeters. And you can use this piece of paper, once the filtration is over, you can use this in order to count, because of the squares there, count the number of particles that are retained. In our case, our effort was not to count. In other words, what we wanted to measure, get a gram or milligram weight of the suspended load in a certain volume of water that was collected from a point in the Naya River. So, in addition to that, we had a flame photometer and a pH meter, locally Indian made and by Sarabhai Instruments, Sarabhai Group, of the Sarabhai Group. And what else? Yeah, these are the equipments. And they did wonderful work, wonderful service in our research. All the equipments were immediate. But one thing I want to talk about is about the balance. Perhaps this is the only two of the Sartorius balances working outside of the VSSC enclave in Tumba. In other words, one balance we had in geology, the other balance that worked is actually in the RRL, Regional Research Laboratory of those days in Papanamooda. Well, of course, there was a third machine purchased by the Department of Zoology and a teacher friend of mine, Dr. Muralidharan. Same equipment, identical rather. It's 46,000 rupees. That is the cost of the equipment. And then this equipment unfortunately got burned. What is called the printed circuit board got burned. And well, unfortunate, and it became a piece of ghost equipment. One other thing is, people in Toronto, we had given free access with permission of the concerned supervising teacher to all those prospective students doing a PhD or whatever, to come over to the geology department with prior notice, and they will be helped by way of weighing their sample in this balance. Not under the supervision, Dr. Prema, our chemist, will weigh the sample in the balance and give the result. And of course, Reena also learned how to operate this balance or the other equipments. We had a UV spectrophotometer that is part of the geology department only, which we made a good deal of use in the analysis of samples, water samples collected for the project. So the project had helped to revamp the chemical laboratory to a very high degree. Now, what about the actual work in the field? We did a river shore walk to begin with, and then we identified what is called the sub-basins on the left bank side and the right bank side of the Nayar Basin, and we had developed on the basis based on a blueprint of a system, just a contraption, which is called a home bedstead type snow accumulation gauge. In other words, this was originally developed by the Canadian Geological Survey in the pre-Landsat days in order to do the actual field measurement of the snowpack accumulation during the snowfall season. Because, in any snowy country, their water resource are actually estimated not only based on the aerial photo based investigations, but also based on taking some ground truth. And this little device, which is 1 square meter area, it's a frame of 1 square meter, and that was actually, sort of modified for our use. In other words, we used this what is called a bedstead type snowpack measuring device to measure the soil loss along the slope, along the summit of the slope, at the summit of the slope, at the midpoint in the slope, and at the foot of the slope. So this was a wonderful study. We made a study, monitoring of the soil loss by making measurements before the monsoon and after the monsoon. It gave wonderful results. Very precise in the sense, to the extent that, we had a sample of 1 square meter. That is the only limitation. But I thought those days, even with the 1 square meter sampling area, is a wonderful step forward in making quantitative assessments of soil loss. Because one of the things, all the sub-basins in the Nayar Basin, they're totaling something like 15. 7 sub-basins on the right bank of the river, and 8 sub-basins that we monitored on the left bank of the river, naturally gave a picture of the soil loss annually through a monsoon season. Because that is what matters in respect to this soil or sediment that is transported by the main stem over to the ocean. And most of the sediment, the texture of the sediment actually, that will tell you what is the level of transport to the ocean. In other words, total load transported by any fluvial system over to the ocean is estimated as a sum of the dissolved load plus suspended load. Dissolved load we estimate through the chemical analysis of the samples of water, whereas the suspended load is actually estimated based on the whatever is accumulating in the filter paper. In our case, it is a sartorius filter paper. So our field studies were actually bi-monthly. In other words, that is how we designed the field study periodicity, and it went on for 22 months. Once every 2 months, we go and monitor these areas. Okay, then I am talking about the water discharge and sediment discharge only, not the soil loss. Soil loss is only a one season study. Then one other thing soil loss is actually needs support from the rainfall also. We have the closest rainfall measuring station to the Nayar Basin was in the Tiruvandhuram city, in the observatory hills in the EMD lab. Whereas there used to be what is called a rain gauge built in and established by the irrigation department in front of what is called the Nayar Dam guest house. But unfortunately, during our first visit to this guest house, told us that there is only a skeleton left because it is made of ordinary tin sheet or iron sheet, and within 4 or 5 years, the whole thing will crumble. And those days, perhaps are not just perhaps. Really speaking, the irrigation department was not very keen about measuring what is called rainfall. Well, it is unfortunate. In other words, all the engineers are taught about hydrology and the importance of hydrology. Once they get the BTech degree or whatever, and they join as an engineer in the irrigation department, the first thing they do is they are asked to forget all about what they learned and simply follow what is practiced in the organization. If it is a design, well, there is actually a design procedure probably invented in the British days, and that is continued even today. Unfortunately, well, I will not say even today, because today the design is not done at all. In the sense, all these designs are by other agencies and expert agencies and are built by contractors. Like, for example, our bridges, flyovers. Larsen and Tubro is the nationally known agency in India who is in charge of developing the four-lane highways and all the constructions related to it. This is the difference. So what we did for measuring the rainfall, we purchased something like 15 rain gauges from Lawrence and Mayo, which is made of fiberglass, and all the glassware inside, a measuring cylinder, and the related stuff, all the glassware that will go into this, what is called the rain gauge, were import from Borosil, United States. And, we identified 15, enthusiasts in the basin. All these, out of the 15, 14 were school teachers. They very gladly accepted our request for doing the measurement during the monsoon season, during the rainy days. Whereas the only one, a lone example was with a political activist who lived in one of the basins, sub-basins, tributary basins, and that is the only equipment or only group or person that failed miserably to turn over any good, reliable data. All the teachers were very enthusiastic. By the way, our teaching community, an average teacher, those days, in the like in the 80s, were very much enthused about the scientific work anybody does, and because they are teachers, and the teachers' role is very important because they are the ones who mold the future experts, future administrators, and future civil servants of the nation as well as of the state. So that part also was done wonderfully well. I will come up with a part of the story, remaining part of the story, in the next episode. Bye now.